Hello everyone, today we're going over 2.6 transformation of functions. So first of all, we have to know how to graph the basic functions that we learned from in the previous sections. The first basic function we have to learn is the function f of x equal, the power function, the linear function. Number one is the linear function. For example, the function number one, the function f of x equal x. So the graph of this function is a linear function. The graph of this is look like something like this. Here is the graph of this function f of x equal x. This is a basic function. We have to learn, we have to know how to graph this function without using the plotting point, because our class today is transformation. We're going to graph all functions without a plotting point or without tables. So we have, but by using depending in the basic functions. Like for example, the first graph for the basic function is the linear function of x equal x. Second function we have to know how to graph it is the quadratic function, is f of x equal, for example, x squared. So this is a parabola. We have to know this is a parabola, and the graph of this function is exactly like a cup. So here is, it look like a cup. So the graph of this function is a parabola. Here is the graph. This is f of x equal x squared. The third graph we should to know is the cube function. So the cube function, the graph of the cube function is something like this. All these functions we graph it before, so we should to know we have idea for these functions because we graph it by using the plotting points in the previous classes. So this is the third one. This function is number 3 of x equal x cubed. So the graph of this function is look like this. Fourth function we should to know how to graph it is the root function. For example, the square root of x. So here, number 4 is f of x equal square root of x. So the graph of this function is look like this. First of all, what is the domain of this function? What's the domain of this function? I mean, for the domain, what is the possible input I can plug it inside this function and keep the function
everything greater than 0?
Exactly. And
greater
what about
than or equal to 0?
Exactly, greater than or equal to 0. Exactly. Mayasha, all positive numbers and the 0 too. You don't have to forget the 0. So the graph of this function look like this. Starting from the 0 to positive infinity. Number 4, we should to know the graph of the function the third root, like for f of x, f of x equal the third root of x, the third root of x. So the graph of, what is the domain for this function? Number 4. What is the domain of this function? The third root of x. Do you know what is the domain of this function? What possible input can I plug it inside this function? Can I plug 0? Can I plug the 0 here, this function? Can I plug 0 inside this function? Yes. What about if I plug positives, like for example, 1, third root of 1? Or yes, so they will give me 1, third root of 8. They will give me 2. So so all positive numbers I can plug inside this function. What about the negative? Can I plug negatives here? This is odd number. For odd number, I can plug negative. For even number, I cannot plug negative. I spoke about this in the first section of this book. For positive, for even, I cannot plug negatives. For odd, I can plug negatives. So here I can plug the third root of -1 is -1. The third root of -8 is -2. So the domain of this function is all real numbers R. Okay. Now number 5. We should to know how to graph the function, the absolute value for x of x, like f of x equal the absolute value of x. So the absolute value of x has a graph like, can we use negative numbers too? Yes, we can plug negative numbers in the here in the third one because this number, the cube root or the third root is odd numbers. Like I said before, the even numbers is even numbers is like 2, 4, 6, and so on. Odd numbers, for example, 1, 3, 5, and so on. So number 3 is odd number, so I can plug negative and positive. But here, the square root, this is here, we have 2 actually, but it's hidden. So inside this one, I supposed to plug only positive numbers and 0. Now for f of x equal the the absolute value of x, the graph of this function is look like this. Let me erase this one here to make a space. Okay, so the graph of this function is something like this. Like this. So this is the graph of the absolute value of the x. Now we have also know the graph of the function f of x equal 1 over x, but we're not going to use it a lot, but we have to know how the graph of the function So this is the basic important graph. We're going to use it during this section or in the coming sections for graphing by using the transformation. Also, we should to know how to graph the function f of x, like I said, number 7. So here we have 6, 5. Here we have 5, 6. Sorry for that. This is 5 here. And here we have 6. Now, number 7 is not very important, but we should to know how to graph it. Maybe you will see some question in Weber sign 1 over x. The graph of this function is something like this. What is the domain of this function? Can I plug 0 here? No, I cannot. Can I plug positives? Yes. What about negatives? Yes. So the domain here is all numbers except the 0. So I cannot plug 0. So the function should be something like this. It will be close to the 0, but they will not touch the 0 at all. So the graph will be something like this. Okay, now number 8. The graph of f of x equal 1 over x squared. So the graph of this function, again, the domain of this function is all positive or all numbers except 0. I cannot plug also in this function the 0 number. So the graph of this function look like something like this. And in this side, like this. Any question? Any question for the graphs? Is it clear? So you should to focus from 1 to 6. This is very important. About 7 and 8 also is important, but not like from 1 to 6. Okay. So after we know the basic graphs, we should to know, now let's go to the starting for this section. First of all, we have to know, last time I started talking about the vertical and horizontal shifting, but I'm going to remind you for the definition for how we can, the definition of, or the rules for vertical and horizontal shifting. For it, the domain will be from minus infinity to infinity. No, will be from minus infinity to infinity except the 0. Except the 0. From minus infinity to infinity except the 0, or I can say x, the domain here, x such that x not equal 0. So domain is x such that x not equal 0. This is mean all numbers except the number 0. All real numbers except the 0, and the same things here, the domain is equal x such that x not equal 0. Okay, Eric? Now the vertical and horizontal shift. This is the section start for this part. So the vertical and horizontal. So first of all, we should to define the C. This C is a number greater than 0. Suppose I have number greater than 0. So the first things we have to know how is the shifting vertically. So the graph, if I need to graph the function y equal f of x, and we adding this C to the graph, and I need to graph the function y. So to graph the function y is we have to graph the function f of x, then we have to shift this function upward C unit. So here we shift the graph f of x C unit. We have graph the function f of x upward C units. This is for f of x plus c, but what about the f of x minus c if we have negative?
It will go downward.
Negative means, and the number, exactly, we shift it downward. If the number is negative here, we shift the graph of x downward C units. Exactly. Now, here, as we see, the C, the number, this number is outside the function. I mean, outside the function is outside the parentheses, is not inside the parentheses. What happens if the number, this number is inside the parentheses? If the number is inside the parentheses, the graph will be shifting horizontally. So this is vertically, this is horizontally if the number is inside the parentheses. So here, look, number is inside. We add x plus c to graph the function x plus c. We shift the graph of x to the left or right. How we can shift it? If the number is positive inside the parentheses, as we learned, as I said last time, if the number is positive and inside the parentheses, we have to shift it to the left. Okay? We shift it to the left, not to the right. And if the number is inside the parentheses and it's negative, we shift it to the right. C units. So it's opposite, positive, left, negative, right. Okay. Also, we should to know this is vertically shifting or vertical, and this is horizontal. Horizontal shifting. Okay. Now let me give you example for this. Example. The example is a graph or sketch by using the graph. This time I'm going to give you the graph, the original function. So by using the graph, f of x equal x square, graph each of the following. Graph each of the following. Number one, g of x equal x square plus 2. Number two, s of x equal x square minus 1, 3, d of x equal x plus 2 square, everything square, and the last one is L of x, number 1, number 4, L or m of x equal x plus 2 x minus 3 square. Okay, for the first one is here we have the function is square, square, square. Here we have square here and square here. Okay, so just I need so the function here, by using the graph, they give me the graph actually of x. The question is direct. By using the graph of x equal x square, we need to graph each of the following. The function, this one, the function of x, let me fix it. 1 second. Here we have the 2 here, square. So the function is given f of x equal x square. I need to graph the function g of x equal x square plus 2. So what does that mean? Which one of this 4 I should to use? So first of all, to graph this one, I have to graph the function f of x equal x square. This is the first step. Second step, to graph this function, I have to back to the rules. Now, g of x equal x square plus 2, how is the shifting here? Is it a vertical or horizontal? And
It's
second
gonna
thing,
be
is it a vertical upward? Yes, go ahead.
it's gonna be up and down because
Up and
oh
down.
no, sorry, it's gonna be side to side. The first g of x is gonna be side to side is because there's no parentheses.
What
Right?
do you mean side to side? Like up and down or left or right?
No, left or right, and the first one is gonna shift 2 units to the left because of its positive 2.
No,
Right?
here, but what about 3? Look to the 3.
3 also moves
You see
left and
3,
right.
3 left and right. What about 1?
Oh, sorry, 1 goes
See
up and
1?
down. No?
Yes, exactly.
Yeah.
1 is up and down because number 2, it's outside the function. The function is x squared. It's outside. But the number 2
Right.
here, it's inside the function. Okay, with the square. You see the square with the square. So this is because the 2, the number is outside. So it should be like up and down. But now, is it up or down? So you go back to the rules, the graph of the function f of x plus 2. So f of x plus 2, this is the function f of x plus 2. We shift the graph f of x upward c units. So we have to shift it 2 units to the up. So we have to graph the function f of x, then we have shifted upward 2 units. So let's doing the first one. I'm going to do the first one and the second one in this graph here. So first of all, to think how to solve something like this, first of all, you should to know the function f of x is x squared is equal x squared. So you plug instead of x squared here you can write this one as g of x equal x squared. We substitute instead of x squared this function f of x because f of x equal x squared. So this is equal f of x plus 2. Now, if you go back to the rules, it will be so easy to find. So here I see the first one, this rule is exactly the same like the first rule. F of x plus t. The c is number 2, is 2. Okay, so to graph this function, we have to shift the graph f of x upward c units. So means we have to graph the first things, the f of x is x squared. Then we have to shift it C unit, I mean like we have to shift it 2 units upward. So the graph of the function f of x equal x squared is look like this. Let me make it correct, like parabola, like as we said in the beginning of this class. Here is the graph of the function f of x equal x squared. This is the graph of the function f of x equal x squared. So we should to graph this function in the beginning. This is the graph of f of x equal x squared. This is f of x. You have to write it down. You have to write the name of the function behind it. So f of x equal x squared. Now to graph this function, we have to graph the function f of x. So we did it already. Then we shift the f of x 2 units upward. So 2 units upward. So it will be like here is the point here is 0, 0. So it will be like this is 1, this is 2. So starting from 2, and everything here will shift it upward 2 units. So the graph will be something like this. Okay, so we shift 2 units upward. So the red function is the function you have to write down g of x equal x squared plus 2. Now for the second one, who will do the second one?
The second one is shift 1 to the down from origin, 1 unit down.
Exactly. This is correct. So first of all, to like simplify or to explain more, because I don't want you to get confused, the function this is s of x. Instead of of x squared, I'm going to plug f of x. So this is equal f of x minus 1. So this is mean if you go back to the rules from 1 to 4, 1, 2, and 3, 4, 3, 4. If you go back to the rules, you will see this rule exactly similar to number 2. Look, up 2 units. Why never? Okay. So for the number 2, if I need to rewrite it, this function, instead of x squared, I'm going to use the f of x. So this is equal s of x equal f of x minus 1. If you go back to the rules, number 1, 2, 3, 4, I will see this is similar to number 2 exactly. Y equal f of x minus c. Here is the c is minus 1. The c here is 1, I mean. But because it's minus, this is mean we have to shift the graph f of x, the function f of x, this function, x squared, downwards c units. So we should to shift the black graph, the black curve, 1 unit down. So 1 unit down, it should be like this, parabola, but it's gonna be like 1 unit down. So this is 0, 0, right? At this point here, it should be minus 1, and all function will be shifted down 1 unit. Like this. This is s of x equal f of x minus 1. Okay, is it clear for the first two example? By the way, you should to write in the graph here, the numbers is 2, and here is minus 1, to know what you did exactly for the function. And also you have to label each function behind each graph, the name of the function. This is very important. The name, and also you have to put the point minus 1. Okay, now let's do the number 3. What is number 3 is? Which one I should use from 1 to 4? Which rule I should use? Eric said number 3. I had to use number 3. This is correct, exactly. So my original function is f of x equal x squared. So if I need to rewrite this function, I can write it as, this is equal actually, d of x equal the function here x plus 2 square. So this is mean I plug x plus 2 inside the function x square. This is equal, is the same as if I plug this one inside the function f. So this is equal the f of x plus 2. And if you go back to the rules from 1 to 4, you will see it's similar to number 3. And the c here is 2. This is mean we have to shift the graph f of x, and the graph of f of x is this one, the original function. This is the original function. We should the graph to shift the original function f of x to the left c units. I mean 2 units, because here we have 2. So to graph number 3 and 4, I'm going to do it here. So so this is the original function is x squared. This is x squared, f of x equal x squared. This is the original function. Now we should to know to graph the function d of x. We have to shift the original function left c units. I mean, we have to shift it to the left 2 units. So to the left 2 units, it's supposed to be the graph like this. So this point should be moved 2 units to the left. This first one, this is the second one. Here's -2. And everything will be shifted to the left. So graph will be something like this. This is the graph of the function. What about the exponent? The exponent, okay, let me explain it more. So the function is f of x, right? My function is f of x, the original function, equal x squared. Now, they ask me to graph the function d of x equal x plus 2 everything squared. So the graph asked me to graph s of x equal x plus 2 squared. So actually here we plug instead of x, this is here, if I need to rewrite this one again, this is equal x everything squared, like this. This is exactly. Okay? F of x equal x squared is exactly equal x parentheses 2. Now, if I plug instead of x, x plus 2, the function f of x will be changed. Okay? Here I can write f of x plus 2. Look, plug x plus 2 instead of x. This is equal, instead of x, x plus 2. And everything squared. Now this function, it's similar to the f of x, to the s of x. Look, s of x equal x plus 2 everything squared. And f of x plus 2 equal x plus 2 everything squared. So actually this is equal s of x. So now I can say s of x equal f of x plus 2. Now, to graph the function s of x equal f of x plus 2, go back to the rules. The graph of the function y equal f of x plus c, here we have a plus. We shift the graph f of x, the original function, to the left, c unit. Here I get question, the parabola should be on the right. No, we have to shift it to the left by using these rules. If positive, left. If negative, right. Safe. You see what we did here? F of x equal x squared, and this is equal the parentheses of x, everything squared. The question is, graph the function s of x equal x plus 2, everything squared. So instead of x, I'm going for the function f of x, I'm going to plug x plus 2. So f of x plus 2 equal x plus 2, everything squared. And this is actually equal to the s of x because s of x equal x plus 2 squared. So this is equal here, this here equal to this. That's mean s of x equal f of x plus 2. So s of x is equal to f of x plus 2. Now to graph this function s of x, we have to graph the original function is the parabola. Then we have to shift it 2 units to the left because we have positive. So this is the graph of s of x. Now the last one, m of x equal x plus minus 3. The same idea like number 3. So this is actually equal m of x equal f of x minus 3. Okay?
Is it going to
Same
be
things. Which rules? Yeah, which rule? From 1 to 4? If
is
you
it going
go
to be
back to
like
the rules,
m of x equals f of x minus
C.
f of
You see this one? C. Y equal f of x minus c. So the same things, f of x minus 3. So we have to shift the original function f of x to the right c units. Okay? So the question is to graph the function m of x equal x minus 3 square. This is equal f of x minus 3. Same step like here. As I said, f of x equal x, everything square. So here we have, if I plug instead of x, x minus 3, I will get f of x minus 3 equal x minus 3, everything square. And this is similar, this is exactly similar to the function m of x because m of x equal x minus 3 square, m of x. So this is mean m of x equal to the f of x minus 3. M of x equal f of x minus 3. This is mean we have to shift the original function 3 units to the right. So here is 0, this is 1, this is 2, this is 3. And everything will be shifted to the right. So the graph will be like this. This is the graph of the function m of x. Any question? This is m of x. Any question for these graphs? For next exam, are we going to focus from 2 point? Yes. Any question for this example? Now we're going to learn how we can combine the horizontal and the vertical shifting. So combined horizontal and vertical shifting. Can you go back? Yes, I will go back. Hold on. Oh, by the way, here we have to focus. This number here is 3. We should to write this now. Here's 3. Any question? Can I move? Okay. So if the question, you're welcome. If the question is so example, graph by using transformation. Graph the function of x equal square root of x minus 3 x minus 3 a plus 4. How we can graph something like this? Here I am combining the vertical and horizontal shift in the same example. So first of all, you have to ask yourself, what is the original function? What is the original function?
Isn't the origin 3 and positive 4?
But no, I mean, like when you ask yourself, Ayman, what is the original function? What is the original? What's the function I should to start a graph? Then
Oh,
I
f
have
of
to
x,
do
f of x equals x squared.
exact, not x square root. Here we have
Yeah.
square root. I mean, the O of x, I mean, for O, the original function of x is equal the square root of x. This is my original function, the square root of x. Why? Because if you go back to the example of x equal square root, so you will see we use the square root as original function. Then, so we should to graph the original function, the square root of x. This is the square root of x. This is f of x. No, not f of x. This is O of x. O of x equal the square root of x. Now, you can do two things to graph this function. You can graph it directly, or you can like fix this function and you see what exactly you have to do like shifting. Then you have to go back to the rules, the 4 rules. So if I need to fix this function, I have O of x equal the square root of x. So actually they plug x minus 3 inside this function. So let me plug inside this function x minus 3 inside this function. So I get now O of x O of x minus 3, O of x minus 3, because they plug x minus 3 inside this function, equal the square root of x minus 3, right? Then you should to add 4 for both sides. So let me add 4 for both sides of the function from outside. You see, I add the 4 from outside. So actually I get O of x minus 3 plus 4. This is equal to the square root of x minus 3 plus 4. Now look, O of x minus 3 plus 4 equals the square root of x minus 3 plus 4, and square root of x minus 3 plus 4 is the same as the function f of x. So here I can write equal f of x. So to graph this function f of x equal the original function of x minus 3 plus 4. Okay, what does that mean? What is the mean of the minus 3 inside the parentheses of the original function?
That means it's gonna move back to +3 and +4.
I mean, like the minus 3 inside the parentheses. What does that mean?
It means you're gonna move to the right.
To the right, how many units?
3 units.
3 units. And what is the mean of positive 4 outside the original function?
You're gonna move up 4 units.
Exactly. So first step, we have to move the function 3 units to the right, like this. This is the head of the function. So this is 0, 0. The first step, we have to move all these points 3 units to the right. So 1, 2, 3, like this. So the function would be something like this. Okay. 3 units to the right, then 4 units to the up. Let's go up. Now, the graph should be 4 units up. So this is 0, 0. Here, 1, 2, 3, 4. So the starting point will be like here, around here. Then we have to graph similar to the red one exactly, like this. And this is the graph of my function. And this is the graph of f of x. Makes sense? This is the graph of O of x, O of x minus 3. Here you should to write 4, and here you should to tell me what is the starting point. Here we have 3, 3 and 4. This is very important, this point. Any question? Can you please explain it again? Okay. So first of all, when you see something like this, the function f of x equals square root of x minus 3 plus 4, you should ask yourself, what is the original function? The original function to graph all this is the square root of x. And the graph of the square root of x is the same as we learned here. This is the graph of the square root of x. You see, this is the graph of the square root of x. This is the plain function. Like, we did not modify this function yet. This is the original one, the basic function. Then you have to modify this function. You have to change a little bit in this function to make it something like this. Like this, all this. So first of all, I'm going to plug x minus 3 inside the function. Why? To make the function similar to this. After I plug the x minus 3 inside the function, I get O of x minus 3, plug inside x instead of x, x minus 3. Now, to make similar to this function, I add 4 for both sides. I add 4 here, and I add 4 here. Now I get O of x minus 3 plus 4 equal this things plus 4. And x square root of x minus 3 plus 4 is the same as f of x. Look, square root of x minus 3 plus 4 is the same as f of x. So I mean for that, all this side, all this is the same as f of x. So f of x is O of x minus 3 plus 4. Now go back to the rules. If you go back to the rules here from 1 to 4, you can sketch or graph the function f of x by using the original function. So first step, you have to graph the original function, the red one, square root of x. Then you have to use the rules. So here we have minus 3 inside the parentheses. Minus 3 inside the parentheses means we have to shift the graph 3 units to the right. Why? By using the rules number 4. The graph of the function f of x minus c, we shift the graph f of x right c units. So first step, we shifted c units, 3 units to the right, the black, this one. This is the graph of O of x minus 3 only. Now, the question asked me, graph the function O of x minus 3 plus 4. So means plus 4 outside the function. This is mean we have to shift the black one 4 units to the up. So the original, so shifting the black one, this one, 3 units, 4 units to the up, it will be here. This is the starting point. The starting point will be 3, 4. Then you have to graph exactly similar to the red one, like this. And that's it. This is the graph of the function that I need. Any question? You're welcome. Now let's go to the reflection graph. So actually, to graph any function like this, I prefer to use this idea. Modify to the original function. First of all, you have to ask yourself, what is the original function? Then you have to modify it to make it similar to the f of x. Then when you get the modify, after you get this function, the original one, but you modify to it, equal to the function I need to graph it, will be so easy to graph. Now we should to know how to graph, how to do. Now the part of the reflection. So we have to learn how we can graph reflection graph. Reflection or reflecting graphs. Reflecting graphs. Okay. Reflecting graphs, it has rules like before. So first of all, we have to know the graph of the function y equal minus f of x. If we need to graph the function y equal f minus f of x, we should to graph the function f of x. Then we have to reflect it around the x-axis. So this is mean reflect the graph of y equal f of x, y equal f of x in the x-axis, Okay, now to graph the function, if the minus this is inside the function, if it's inside like this, if it's inside, so we reflect the graph of y equal f of x in the y-axis or around the y-axis. Okay, let me explain, let me graph. So suppose my function look like this. This is my graph of the function. My function is something like this. This is the function f of x, and the question asked me to graph, and this is also, suppose this is my f of x, and the question for the first one asked me to graph the function y equal minus f of x. So the graph of the minus y equal minus f of x, we reflected around the x-axis. This is mean we reflected around the x-axis. We put the mirror around the x-axis like this.
So
This is my mirror. So
yeah.
this is my mirror. And here to graph the function y equal minus f of x, my mirror is the y-axis. Okay, so for the first one here, to graph the function minus would be around like this, reflecting everything around this. So it's gonna be like this things here.
Yeah, don't you have to go exact points from the origin? So for example, the original function is 5 units away from the origin. The reflection would also be 5 units down from the origin. It's to be exact. I mean, yeah, of course, the graph is gonna be something like that. But if you want to know the
Yes.
exact numbers, don't we have to go from the origin, the exact number, the exact distance it went from the origin up? It's gonna go. It's also gonna go down.
Exactly. Exactly. So the distance he like Shab, he said the distance between the x-axis to this point is the same as from x-axis to this point. So the distance from here to here is the same. Also, here the same things. The distance from this point to the x-axis is the same from x-axis to this point. So the distance here are the same. And the distance here is the same also. So to graph the function minus outside, you see the minus is outside the function. We reflect the original function f of x around the x-axis. Now to graph the function, this one, but the minus is inside the function. To graph the function f of x, f of minus x. So this means we have to reflect everything around the y-axis. So it's going to be something like this. Something like this. This is the graph of the function f of minus x, f of minus x. Okay? Any question?
So which coordinate do you make a change in? The x or the y?
Coordinate for which one? For the
I mean,
first or the
to
second one?
reflect. I mean, don't we have to imagine we have a set of coordinates, and don't we have to change the signs to show that it's reflecting somehow by changing the signs of inside the parentheses?
Yes. If, for example, I have like order pairs, x comma y here. Here would be like x comma minus y, like this.
Yeah. So
If the point
so when
is x.
so when
Yes,
we're
go ahead.
reflecting, so we're basically changing y into a negative, positive y into a negative y.
Yes.
Yeah. And then
Exactly.
for the other part, we're just changing the
If I
x,
have
negative x to positive
exactly
x,
minus x, exactly
and the
minus
y stays the
x
same.
and y the same y. But yes, this is correct. Okay, so let me give you example for how we can use the graph here, the rules. So the example is graph each of the following. Number one, f of x equal minus outside x square. Second one is g of x equal square root of minus x. Okay, again, the first one is minus x squared. For the second one, is the square root of minus x. Okay, so for the first one, what is the original function? For number one, what is the original function before I do
Original
everything?
function is f of x equals x squared, positive x squared.
Exactly, x squared. This is the original function. Now, what I should to do to change the original, what I have to modify for the original function to make it exactly similar to the f of x?
You simply get the negative to the f of x.
How can I get the negative here to this one? What I should to do?
You write negative f of x. So
I have my function is f of x equal minus x squared. I need to change something in this example, in this original function, to get f of x equal minus x squared.
you simply move the negative move the negative to f of x, and
What
you
if I multiply? What if I multiply? What if I multiply by minus 1 for both sides? Again, I need to change something in this to make it similar to this.
it's gonna
I
be
need to change
is it gonna be negative O of f of x equals x squared, negative x
exactly,
squared? Yeah.
exactly. So again, I have to do something in this, the red one. You see the red? We should to multiply or subtract or substitute inside this function to make it similar to the f of x. We have to change something in this to make it similar to the f of x. So the best things here to multiply both sides by minus 1. Multiply both sides by minus 1. Now I'm going to get minus O of x equal minus x squared. Now look, minus x squared is similar here, minus x squared. And the minus x squared is the same as f of x. Now, I can write here, this is equal to the f of x. Now, I can write here also f of x, just changing the position. So f of x equal minus outside O of x. And actually, I know the original function. The original function here, it's x squared. I know how to graph the x squared. The x squared is a parabola. It's look like a cup. And then the outside, it's multiplying by minus. Going back to the rules, number one, number two, the rules said if the minus is outside the original function, if the original function multiply by minus 1, so to graph this function, we have to graph the original function, then we have to reflect it around the x-axis. So let me do it. Here is the Cartesian plane. Here is the original function, x squared. Here is the function x squared. Now they ask me, now after I go back, f of x, this one, equal minus outside O of x. This means we have to reflect the original function around the x-axis. The minus is outside. So the graph, this is mean, here is the reflect, here is my mirror. This is the mirror. This is my mirror. Now I have to reflect every point around this mirror. So the point here is 0, 0. It will be here, and everything will be moved down. So this is the graph of the function x squared. this is minus, here you should write f of x, this is minus f of x equal minus O of x, I mean minus x squared. And the black one, you have to write, it is the original function. The original function mean O of x equal x squared. Any question? Any question for the number one? Do you have a question for number one? Is it clear what we did? Okay, now number two, g of x equal the square root of minus x. G of x, number two, g of x equal the square root of minus x. Okay, actually we have to know what is the original function. What is the O of x?
The original function is O of x equals square root of x.
Square root of x. Okay. Now what I should to do here, what I have to substitute, multiply, to modify this function to make it similar to g of x.
You have to multiply by -1.
If I multiply both sides by -1, I get negative O of x equal negative square root of x. And this is not the same like g of x. So what I should to do?
It's going to be inside. So it's going to be
Inside.
O of negative x equals.
Nice, nice. O of minus x multiply by both sides inside. Multiply by -1 inside. I mean like not multiply by minus side, not multiplying by -1 inside, just substitute inside a minus x, substitute. I'm going to substitute minus x inside. So I get the square root of minus x. So O of minus x equal square root of minus x. Now go back to g of x. Square root of minus x is the same as g of x. So this is equal g of x. Now
So
to
it's
graph
O of negative x equals g of x.
exactly, g of x is the same as O of minus x. Now go back to the rules from 1 to 2, rules of reflection. The minus is inside, look, the minus is inside the parentheses. This is mean we have to reflect the original function. This is the original function around the y-axis. My original function is the square root of x. Okay, so
Professor,
this is my.
I have a question.
Yes, yes.
What is the difference between g of x, this function, and the other function that we are multiplying inside, and the other one we're multiplying outside? You see
Here we
here?
multiply outside because I
Oh,
get.
yeah, because there is no square root. I understand. Okay, cool.
Exactly. So let's go back here. So here I substitute minus x inside the function. Instead of x, minus x instead. So here we substitute. But here we multiply by -1 outside. So when I substitute minus x, I get O of minus x equal the square root of minus x. And the square root of minus x, if you go back here, is the same as g of x. So actually g of x equal the O of minus x. This is mean we have to graph the original function. This is mean here. We should to graph the original function. This is my original function, square root. How I know? From the first slide, look, square root, this one. So square root of x, this is the O of x, the original function. Then I should to reflect it around the x, the y-axis, because the minus is inside the parentheses. So my mirror here, it is the y-axis.
Professor,
Yes.
in the exam, a lot of the times, no, sorry, in the last exam, for a lot of the examples, they were asking for like perfection. So do we have to know how to graph it like perfectly?
Yes.
Or yeah, so we
Yes.
have to we have to draw like tables and whatever we have to do to make the perfect coordinates. Or we
Exactly.
can't just show the reflection.
Exactly.
So are we gonna
Okay,
do
this
this?
is yes, go ahead.
So
So perfectly means you have to graph it, yeah, like perfectly means we have to show the the mirror. You have to like write g of x. You have to label the function. For example, you don't have to just write the red one and that's it. You have to show me g of x equal o of minus x, for example, or g of x equal the square root of minus x, like this. And you have to show me this point is 0, 0, for example, 0, comma 0. This is what I need. For the previous one, you have to show me this function. You have to label this function, not just you have to draw it. Because I don't know which function you actually, this is which function is f of x and which function is o of x. You have to write down here like f of x equal minus x squared. You have to write down, for example, this point is 0, 0, to show me you understand what you did. Understand? Okay? Show me you understand like like you show me your work for the example, and you will get like full points for if you show me the important points, like label the function, you show me
and
the
Professor,
points like 0,
regarding
0.
the exam, I was here a bit late. I don't know if you discussed it already. Are the grades are gonna be in anytime soon?
No, if you get late for the example, let me talk about this later.
No, no, no.
If you
I'm not late for the. I wasn't late for the exam. I was late for this class. So I don't know if you guys discussed about the last exam already. I want to know by when
oh,
are we
okay,
gonna
okay,
get the
okay.
grades.
No, I okay, so okay, now let's go to the vertical stretching and shrinking of graphs. Any question about this? Any question about the examples here? Okay, let's do the vertical stretching. You don't have office hours, right? Yeah, I have office hours. You can like do appointment by email. If you email me, I can like do office hours with you. Okay. Now the vertical stretching and shrinking of graphs. Okay, what does that mean? Now we have different rules, is the vertical stretching and shrinking. So
Is it?
we
I think
going to, yes, go ahead.
I remember um from from the function ax squared plus bx plus c. The larger the value of a, the smaller the shrink more shrink it gets the graph, and the smaller the number of a, the more stretches it out. I think, is that something like that? I forgot. It was a very long
Yes,
time
this
ago.
is, yeah, this is correct. We're going, yes, like if, first of all, like we have two types of stretching and shrinking. It's a vertical and horizontal.
I've
Let
never
me,
done.
yeah,
Yeah. Go
yeah.
ahead.
So let me explain it. So the vertical, I'm going to start for the vertical stretching and shrinking. So we have the same like before rules. The rules is if to graph the function, for example, if I need to graph the function, y equal c times f of x. Before we talk about when we add c and when we subtract c, but today, I mean, like for this part, we're going to multiply the c with the function. When I multiply the c, so we have two rules. If the c it's outside, so we're going to do stretching and shrinking vertically. But if this c is inside the function, inside the parentheses, we're going to do the horizontal stretching and shrinking, okay? So, but before in the previous slides, we was talking about shifting. Look, the c is we add c, we subtract c, we add c inside the parentheses, we subtract the c inside the parentheses. But now we're going to multiply the c by the function. So when we multiply the c with the function, this will be like different story. It will be like shrinking and stretching. So first of all, we're going for the first part, it's the vertical shrinking and stretching. So if I have to graph the function y equal c times f of x, so we have depending on the c. So we have two rules, very important rules. Rule number one said, if this c is greater than 0, I mean greater than 1, so we're going to stretch the function, stretch the graph y equal f of x. Okay, so to graph the function c times f of x, and if this c is outside and this c also in the same time is greater than 1, we have to stretch the function, stretch the graph of y equal f of x vertically by factor of c. This is the first rule. Second rule, if this c is between 0 and 1, 0 less than c less than 1. So if c this is a small number, like 1/2, 1/4, 1/5, this numbers is c. If this c is a small number between 0 and 1, then we have to do shrinking. But the shrinking of the graph y equal f of x is vertically, not horizontally. It's a vertical by factor of 1/c. I'm going to explain this by graphing. So suppose my graph, suppose I have two graphs. This is my first graph. I'm going to show you how we can do shrinking and stretching. So suppose my original function look like this. This is my original function. This is the function of, let me make it more. This is the function f of x. Now the question is ask me to graph the function c of c times f of x. F of x, and this c is a number greater than 1. C is greater than 1. So go back to the rules. The c is outside the function and the c is positive. So the c is greater than 1. We have to do stretching vertically. So stretching vertically mean this here, the point here will be here. This point will be here. And we're going to do stretching like this. We're going to stretch the function. And also the same things from this side. So the red one is the graph of c f of x, such that c is positive, greater than 1, sorry. Now, If I need to graph the function c times f of x like this, c.
I have a question.
Yes, go ahead.
Doesn't doesn't stretching mean we're gonna move from side to side, like we're gonna move the points like that, or
No, it's not moving the points from side to side. Means we have to hold this point in the x-axis, then we have to stretch the function here in the middle like this, like the graph of the red. You see the graph of the red like this. This is mean stretching. Goes up, and here it goes down. This is mean stretch. Now shrinking means we have to push in the graph. If
oh,
this
right,
c
right.
is
Yes, shrinking
yes,
and stretching is
yes,
different.
exactly. For the second one, c times f of x and c between 0 and 1, this is mean we have to hold this point and we have to push in this function, the black one, to down. And the same things here, we have to push it. So the blue one is c of x, c times f of x, such that c between 0 and 1. Okay? Is it clear what we said, what we did here? Again, to graph the function y equals c times f of x, so first of all, we have to know the c is outside the function, number one. Number two, we have to see the value for c. If this c is greater than 1, we have to do stretching for the function vertically. If this c is between 0 and 1, we have to do shrinking. Shrinking means we have to push vertically to the function. Like this and like this. Vertically. Now we're going over the horizontal, stretching and shrinking. Any question for this example? Over the graph, I mean?
Professor, I have a question.
Yes.
Just the test in exams, do you specifically make the questions or the board does?
What do you mean?
Who makes the test questions, you or the board?
Me.
Okay.
Yeah. Okay, so now for this one, for if c again is greater than 1, we do stretching. If c is between 0 and 1, like 1/2, 1/4, 1/5, we do shrinking. Shrinking mean we push to the black curve. See the black curve, we push down close to the x-axis. Now horizontally. Horizontal. Stretching and shrinking. Same idea. So if C is inside the parentheses, so the question here, the same like before, but to graph the function y equal, so to graph the function y equal, here the C is inside, C times x, C times x. To graph the function y equals C times x, we have to follow the rules. The rules said if this C is greater than, so let me start from here. If C between 0 and 1, we have to do stretching for the graph. Then we have to go to do shrinking. Is the opposite. Stretching the graph y equal f of x horizontally by factor of 1 over c, and the same things for the second one. Okay, the same idea, but here is opposite. If c is between 0 and 1, like small, 1 over 4, 1 over 5, 1 over 6, we have to do stretching for the function f of x to graph this function. And the stretching is horizontally. But if c is greater than 1, like 2, 3, 4, 5, we
I
have to
have a
do
question.
shrinking horizontally. Yes, go ahead.
So, for example, before we do shrinking and stretching, just for example, the original function, right? If
Yes.
this if c is greater than 0, that means, as you said, we multiply by 1 over c. Does that mean we just multiply all the coordinates? We multiply the coordinates of x and y by 1 over c. So we get a smaller number, and then we stretch, and then we plot the new points.
Yes. Yes,
That's how you
exactly.
do it, right?
Yeah, I understand what you said.
Yeah.
Yes.
And for the second question is to shrink. I'm sorry, the other way. If c is
Okay.
if c is greater than 1, how, or do you
Okay.
multiply again the coordinates, or what do you do?
If c is greater than 1, we have to multiply the coordinate by c.
By c itself, right?
By c itself.
Um.
For this one, for the horizontal.
Okay.
I'm going to explain this
Yeah,
by
makes sense.
example.
Makes sense.
Let me show you by graph. It will be more easier for you and
Yes.
for the student too. So suppose my graph, like for the f function f of x, something like this. Same like before. This is the graph of the function, the original function, f of x or o of x, whatever. Now I need to graph the function f of c times x, and this c is between 0 and 1, like 1/2, for example, or 1 over 4. Look, the c is inside the parentheses. This is mean we have to do stretching horizontally. Stretching horizontally. Stretching horizontally mean we have to fix this point, and the point horizontally mean will be here. So the graph, the new graph for this function will be like this. And the same things here. This is stretching horizontally. This is f of c times x. And this c is between 0 and 1.
Somebody asked where'd you get the original function from? I think I can explain this. So every function has an origin. Like there's always an original function before you can transform, reflect, dilate, rotate, whatever. There's always an original function. Like for example, a linear function, it'll go through a straight line through the origin. A square root function would have a curved out of the origin. So you have to really memorize the original functions before you can translate, dilate, rotate, or whatever transformation you're going to do after, I think.
Okay, perfect, nice. Yes, like Shop, said, we like if I need to graph the function, for example, x minus 2, we have original function before we did this. The original function is, for example, square root for x. Like to graph the function x square minus 4, we have original function before we did this is x square only. You understand?
And Professor, in the exam, for example, stuff like these, the original function is going to be given, right?
No, it's not given. Like some of them is given, like the example before. You see, this example is not given. Graph the function. So you have to know what is the original. But some example is given, like this example, by using the graph. You see, is given here. Here is not given in this example. So you have to know what is the original. But for example, like this he asked me, Mayasha, she asked me about this example. This is the graph here, the original graph f of x is from me.
Yes, Professor,
Okay,
I want
this
to
is
know
from me.
particularly this one only.
Yeah, this is from me. If I told you, for example, suppose like this, suppose my original function looked like this, the black one. How is the graph of f of c times x? Like this is given, you know what I mean? Like f of
Yes, I
x, the
got it.
black
Thank
one.
you so much, Professor.
Yeah, this is given. Now to graph the function f of x such that the c is greater than 1, this is mean we have to do shrinking and horizontally. Shrinking mean we have to push everything to the y-axis. I mean, like horizontally means like everything we have to push it to the y-axis. This is mean horizontally like this, horizontally like this, or sometimes like this. It depends. So horizontally and shrinking. Shrinking means we have to push it close to the y-axis. So this is my point here. So to graph the function f of x equal, I mean to graph the function f of c times x such that c is greater than 1. C is greater than 1. Like for example, 2, 3, 4, 5, the graph will be like the blue curve. We did horizontally and shrinking. But here is vertically. Vertically means like this or something like this too. It depends on the value of c. If c is positive greater than 1, we do stretching like up. If c between 0 and 1, shrinking. We push close to the x-axis. Here close to the y-axis. Okay, so now we have example. We're going to do this example next time, but let me write it down and think about this example. And next time we're going to do to graph it together. So the example is, here is the example. Using the graph O of x, the original function, equal x squared to graph or to sketch each of the following. So number one, graph the function by using transformation g of x equal 3 times x squared. Look, the 3 is outside the function. Number two, here x squared. Number two is h of x equal 1 over 3 x squared. Here we have x squared. Here 3x squared. And here we have 1 over 3 x squared. Okay, next time we're going to graph this both by using the rules, a graph by using the horizontal and vertical stretching and shrinking. But let me give you the idea here fast. Is this horizontal or vertical? And is it stretching or shrinking?
This is gonna be shrinking.
First of all, is it horizontal or vertical?
Um,
So to know
Uh,
it's horizontal or vertical is depending in the C, is outside or inside the function.
oh, it's inside, so it's gonna be side to side. No, it's outside, no?
Outside, because the square is for the variable only, is not for the three also. So it's outside. So
Right.
here I can say outside.
So it's gonna be up and down, is it?
So up and down, like vertical. And because the three is greater than one, what does that mean?
It's gonna be shrinking.
The greater than one is
It's gonna be
stretching.
shrinking. Oh, stretching.
Go back to the rules here. So the vertical, this is vertical, and the C is greater than one, stretching the graph. We stretch. So stretch. And vertical. For number two, the 1/3 is outside the function or inside? I mean, like outside, it doesn't have the square root, or outside. The 1/3 is outside the variable.
Professor?
And 1/3 is between 0 and 1 or greater than 1.
Oh, Professor?
1/3 is between 0 and 1. Yes.
I think
Go ahead.
if C is greater than 1, I think it should shrink, not stretch. I'm not so, forgive me if I'm wrong, but as long as I remember.
Yeah. If C is greater than 1 and the C is outside, look, if C outside the function, you see outside the function, and the greater than 1 is stretch. You see the rules? Stretch. But if C is between 0 and 1 and the C is outside the function, is shrink. We shrink the function. But for this one, if C is inside and C between 0 and 1, we have to do stretch.
So we have to
If C
flip.
greater than 1, we have to shrink.
So so it matters whether it's outside or inside, right? So if it's
No,
inside,
it's very important.
so it's if it's
So here
inside,
is the outside. Let's go ahead.
if it's inside, then if C is greater than 1, then it's gonna be a vertical stretch, right?
Shrink. Look
Shrink.
here. Yes, shrink.
No, I said if C is
If
outside.
C outside, if it's outside, here is outside, and the C is greater than 1, like 2, 3, 4, 5, 100, shrink, stretch.
Okay.
Okay, stretch.
Yeah.
Inside, I mean, like if the C 1/2, 1/3, 1/4, shrink. Okay. I'm going to go over this example next time, and have a good day, everyone. See you next time. You're welcome.